Well, hey there, kiddos. Here is your first video on the laws of exponents. This is the first day we're going to talk about the laws of exponents, and you're going to take notes in two different places. You're going to take notes in your packet on the page of notes, and then you're also going to take some notes on the back of your agenda page to your packet. I'll tell you which ones need to go where. It should be pretty obvious, though. The first part, we're going to start right here. This is what your notes look like. This is how they start. So the first thing we're going to do is talk about some definitions really quick. And so we have an example here, this a to the third. Got to find my pen, hang on. And when you have an example like this, an a to the third, it has two parts. It has a base, which is the a. We call that the base. And then the 3 is called the exponent. The whole thing, base and exponent, when you put it together, is called a power, because I have a to the third power. That's how you say it. So the a is the base, 3 is the exponent. And so what does 3 to the third mean? Well, it means that I have to do 3 times 3 times 3. And if I multiply that all out, I get that it equals 27, because 3 times 3 is 9, and then 9 times 3 makes 27. So the next question, what does x to the fourth mean? Well, that just means that I have to do x times x times x times x, which means x times itself 4 times. So to rewrite this expression, we've now dealt with writing them out expanded form. Now we're going to scrunch it back up. I've got 3 times x times x times x times y, and I've got to simplify it all back down. Well, the 3 is the only number, but then I have 1, 2, 3 x's, so that becomes x to the third power, and then 2 y's, and so that becomes y squared. And so that's where we're going to start. We have powers, which have a base and have an exponent. You have one more new word. If there is a number out in front of the base and the exponent in front of the power, that is called a coefficient. And we'll have to discuss that as we go on, because you treat coefficients differently than you do exponents. So now on the back of your notes, on the back of your agenda where you have blank space, we're going to start filling in some things, and we have 3 things we're going to write down today. We're going to write down expanded form, we're going to write down to the power of 0, and we're going to write down negative exponents. We are also going to jot down some rules about multiplying things with exponents. So expanded form is just when we take the number x squared y to the fourth z, and we write out the base times itself, that many times, however many the exponent says. It's just when we rewrite this, and we sort of saw some of this when we were doing the first few examples. So x squared would be x times x. Y to the fourth would be y times y times y times y, and then your z. So that's what it would look like in expanded form. That's just when we write it out in the long expression instead of squishing it all together and using the exponents to denote what's going on instead of writing it out long ways. So we're going to come back to these other two in just a second. We're going to talk about using expanded form and then simplified form and how it works, because we need to talk about negative exponents, which we haven't really discussed yet, but we will. So we're going to start with this table. We're going to start with 3 to the first power, because that one we understand. 3 to the first power means I'm going to write a 3 one time, and so simplified version, it's just 3. 3 to the first power is 3. 3 squared means I'm going to do 3 times 3, which means I get 9. And 3 to the third means I have to do it 3 times, and when I multiply that out, I get 27. 3 to the power of 0. Well, I cannot write 3 down 0 times. 3 to the power of 0, this is where we'll get to that rule. I'll go back to it in just a second. 3 to the power of 0 is going to equal 1, because anything to the 0 power equals 1. Anything, it doesn't matter what it is. Anything to the power of 0 is equal to 1. 2 billion to the power of 0 is equal to 1. Tyrannosaurus Rex to the power of 0 is just 1. It doesn't matter what it is. If you put it to the power of 0, it equals 1. That's a rule you need to memorize. It does not equal 0. Don't make that mistake. It equals 1. So if we're going to do examples of anything to the power of 0, if I have a times b, all of that to the power of 0, it's equal to 1. If I have an example like this, a to the 0b squared, well, the a to the 0 equals 1, so I end up with 1b squared. Well, I don't have to write the 1, I can just put b squared. So it, in essence, cancels itself out of that expression. So anything to the power of 0 is equal to 1. So there's no expanded form for that, but there is the number. Now, 3 to the negative 1 power does not mean that I write it down as negative 3. If we're going to talk about negative exponents, you're going back to the back of your agenda. If we're going to talk about negative exponents, a to the negative n, something to a negative power, a to the negative n is the same thing as 1 over a to the positive n. So you have to cross the line to change the sign. In order to convert a negative exponent into a positive exponent, and that's what our goal is. We want them to all be positive exponents because you're not fully simplified as long as you have negative exponents in the expression. So I want to make them positive, and so to do that, I have to cross the line. So I'm going to have to write it as a fraction. So if this was over 1, this has to cross the line down into the denominator so it becomes positive. So if I have an example like this, x to the negative 2, it's just like having x to the negative 2 over 1. Well, I've got to cross the line to change the sign, so this has to go to the denominator. And so it leaves a 1 on top because there was a 1 in front of it, so it's going to leave this 1 on top. And in the denominator, I now have x to the positive 2 because when it crosses the line, it changes the sign. And if you have an example like this, 1 over a to the negative 3, now the negative exponent's in the denominator. Well, I still have to cross the line, so now it has to come back up here to the top. So that becomes 1a to the positive 3. And if you want to write it as a fraction, you put it over 1, but you can just write it as a to the positive 3. So it has to cross the line in order to change the sign. So when we're filling in this table, this 3 to the negative 1 is really the same thing as 1 over 3 to the positive 1 because it has to cross the line. And if I simplify that, that's just the number 1/3. It's 3 to the 1/1 power is just 3. This 3 to the negative 2 becomes 1 over 3 squared. So remember, it has to cross the line, which is the same thing as 1/9. And then my 3 to the 3rd is or negative 3 is 1 over 3 to the positive 3, which is 1 over 27. So negative exponents become fractions. Positive exponents, you just multiply the number times itself that many times. But the thing to remember about negative exponents is if they were not a fraction, they turn into a fraction. Because that's the only way to make that work. They do not become negative numbers. Do not write 3 to the negative 1 as negative 3. It doesn't work that magically. They become fractions, not negatives. So now we're going to do some simplification, but before we do that, we need to talk about a couple of other rules. No, we do not. I lied. So we're going to simplify these, and we want to simplify it and not have any negative exponents. That's really all I want to do. So if you look at example 5 here, I've got x squared y to the power of 0. Well, remember that y to the power of 0 becomes 1, so you end up with x squared times 1, which is just x squared. So in essence, it canceled itself out, and you just get x squared. Number 6, that entire thing is to the power of 0, so it equals, that's right, 1. Number 7 is just the number 5 with a negative exponent, 5 to the negative 4. So that's the same thing as having this 1 on the bottom. So remember, it's got to cross the line to change the sign, so it becomes 1 over 5 to the positive 4 power. Now, if you want to get your calculator and ask it to do what 5 to the 4th power equals, you can simplify this even further and say it is 1 over 625, because that's what 5 times 5 times 5 times 5 equals. Both of these are correct. To be simplified completely, it has to be here. There can't be any exponents remaining. So number 8, we have 3a all to the negative 2 power, which means I've got to rewrite it. So again, I've got this 1 here, so I've got to make it cross the line to change the sign, and the whole thing is to a negative power. So the whole thing, 3a, has to be squared in the denominator, and it becomes positive. And we'll discuss tomorrow how to simplify this kind of a problem, but for now you're going to leave it like that. So number 9 is just the opposite. It's already a fraction, but it has a negative exponent, so you've got to cross the line and move it back up to the top, which makes this 1 times x to the positive 2, or just x squared. Number 10, I've got x squared and times y to the negative 4. Well, the only thing that has a negative exponent is just this part. The x squared has a positive exponent, so the x squared gets to hang out in the numerator all by itself. What has to get moved is this y to the negative 4. That's what has to cross the line, so this becomes y to the positive 4. And you can't do anything else with that. That is simplified completely. Same with number 11 here. The 4 does not have the negative exponent on it. The only piece in this numerator that has the negative exponent is the m. So this m to the negative 2 is going to have to cross the line to the bottom, while this p to the negative 3 that's down here in the denominator is going to have to cross the line and come to the top. So really they're just going to switch places, but the 4 gets to stay put. So the 4 will stay in the numerator. This will become p to the positive 3, and then the m squared scoots to the bottom. So here's the thing to remember. If you're going to have a negative exponent and you need to write it as a positive exponent, remember it's got to cross the line to change the sign. Make it cross the line. If it's in the numerator or by itself, it's got to move to the denominator. If it's in the denominator, it has to move up to the numerator. It must cross that fraction bar, otherwise it doesn't become positive. Coefficients, unless they have a negative exponent, stay put. So like this 4 right here, got to stay put. Things with positive exponents you don't have to move, only negatives. The other thing to remember is that anything to the power of 0 is equal to 1. So that's what I want you to get out of this, those two things. I'll probably ask you about them when you come to class tomorrow, and I'll see you then.